Last year, you watched me die on every single planet in our solar system. For the sake of science, I was crushed on Jupiter, frozen on Neptune, and suffocated on Mars. But apparently, that wasn't enough for the What If team. This year, the stakes are being cranked up to the absolute limit. We're heading to the absolute worst neighborhoods in the known universe. We're talking supernovas, black holes, and galactic clusters reaching 160 million Kelvin. And before you ask, no, that's not 160 million guys named Kevin, though that would also be terrifying. We're bringing the heat, the gravity, and the total atomic annihilation. I really need to renegotiate my contract, but until then, buckle up. We're starting with the big guy in our own backyard, the sun. We all love the sun from a safe distance of 150 million kilometers, but up close, it's a G-type main sequence star, a galactic furnace 1.4 million kilometers across. In 2024, the Parker Solar Probe made history by dipping into the sun's corona, just 6.1 million kilometers from the surface. But we're going deeper. To land on the sun, you'd have to survive the corona first, an atmosphere that is mysteriously hotter than the surface itself, topping out at 2 million degrees Celsius. Scientists believe this is due to magnetic reconnection, where magnetic lines snap and release massive bursts of energy. If the radiation doesn't fry your ship's circuits instantly, the gravity will. At 28 times Earth's pull, you're not landing, you're being reclaimed by a giant. And remember, there's no solid ground. You're landing on the photosphere, a churning sea of plasma that's basically lava soup. Let's see if I can last 5 seconds. Actually, we have to do this in slow motion because seconds don't really exist in a place like this. At 5,500 degrees Celsius, the photosphere is bright enough to turn your retinas to ash instantly. Within 0.1 milliseconds, your state-of-the-art spacesuit chars, warps, and the visor liquefies. Within half a millisecond, the suit is compromised. Boiling plasma hits your body like a physical shockwave. You wouldn't feel hot. You wouldn't feel anything. Your nerves would vaporize before they could send a signal to your brain. It's hot enough to boil diamonds. Within 10 milliseconds, your flesh, bones, and DNA are turned into an ionized gas. You don't just die, you become part of the sun's fuel. Talk about a heavy ending. If the sun was too bright for you, let's try the opposite. This is Gaia BH1, the closest black hole to Earth, sitting about 1,500 light-years away. It's a stellar mass black hole, the living tombstone of a giant star that ran out of fuel and imploded. It's 10 times the mass of our sun, but packed into a tiny invisible point. As we approach the accretion disk, the swirling whirlpool of superheated gas, the ship starts to groan. This is a gravity well so deep that not even light can climb out. Once you cross the Schwarzschild radius, the point of no return, physics as we know it takes a permanent vacation. Jumping into a black hole isn't just a fall, it's a transformation. It's called spaghettification. Because gravity is so much stronger at your feet than at your head, your body is stretched vertically and squeezed horizontally. Your spine shatters, your skull elongates, and you become a human noodle miles long. But here's the kicker. Time warps too. To an outside observer, I'd look like I'm frozen at the edge of the event horizon forever, slowly turning red and fading away. But from my perspective, I'm plummeting toward the singularity, watching the history of the entire universe flash before my eyes in a matter of seconds, before gravity finally tears my atoms apart. You want to avoid the noodle effect? Fine, let's try something denser. This is RxJ 1856 35 37 54, the closest neutron star to Earth. It's only 20 kilometers wide, but don't let the size fool you. A single teaspoon of this star would weigh 1 billion tons. This is degenerate matter, atoms crushed so hard that electrons and protons merge into pure neutrons. The surface is 10 billion times stronger than steel. As we approach, the magnetic field is so powerful it literally reshapes the atoms in your body into long cylinders. Before you even touch the surface, the X-ray and gamma-ray radiation would boil your blood and dissolve your cellular structure. If you did manage to hit the surface, you'd be hitting it at a significant fraction of the speed of light. You wouldn't just be crushed, you'd be incorporated into the crust of the star, a layer of nuclear pasta thinner than a sheet of paper. If you think stars are scary, let's look at the big one. Meet El Gordo. That's Spanish for the fat one. It's a galaxy cluster born from the collision of two massive clusters billions of light years away. This is one of the hottest environments in the universe. We're talking 160 million Kelvin. When galaxy clusters collide, the dark matter passes through, but the gas clouds slam together, creating a cosmic shock front. If you were floating here, your ship would be hit by a wave of gas traveling at thousands of kilometers per second. It's the ultimate intergalactic smash-up. You'd be ionized instantly, your body turned into a cloud of subatomic particles scattered across millions of light years. Finally, the grand finale. Supernova SN 2016 APS. This is the brightest, most energetic supernova ever recorded. It's a pulsational pair instability event, where two stars merge before the explosion, creating a blast 100 billion times brighter than our sun. If you're within a few light years, the first thing that hits you isn't light, it's a ghost flood of neutrinos. Usually, neutrinos pass right through you, but in a supernova this big, the flux is so intense it would heat your body to millions of degrees from the inside out. Then comes the shock wave at 10% the speed of light. Within 10 milliseconds, you aren't just dead. Your atoms are being carried away to seed the next generation of stars and planets. You want it epic? That's about as epic as it gets. So, where should we go next? I heard Venus is particularly good at making things die. But that is a story for another What If.